Welcome back to More Life. I'm Jody Dean. I'm sure we all know there are a lot of very smart people working right now to find not only a treatment for COVID-19, but a vaccine as well. A lot of the research that's happening right now involves drugs we've already heard about, some of them controversial. Will they work? Or more precisely, will they work on COVID-19? Almost all medicines have side effects. The question is the human cost of those side effects worth the gain to patients that the medicine might provide? Now, doctors take an oath to do no harm, which is why they're very reluctant to try anything that has the potential to make bad problems even worse. Most of us would probably act the same way. But that doesn't mean doctors and scientists aren't studying every possible means they can think of for defeating this particularly nasty virus that we're dealing with right now. And sometimes the oddest thing can make the biggest difference, like cantaloupe. Throughout human history and well into the first part of the 20th century, the one thing that killed the most soldiers in war wasn't getting whacked with a sword or shot with a bullet. It was infection. You might survive the battlefield, but there was no real way to fight the diseases or sepsis common to the trenches and field hospitals. In World War I, the fatality rate from bacterial pneumonia alone was about 18%. Nearly 20 out of every 100 soldiers who caught it died. But in World War II, that number fell to less than 1%, at least for the Allies. So what changed? Well, what changed was that a scientist by the name of Alexander Fleming went away for the weekend. Fleming, a physician, was a Scot who had served as a medic in the British Army during the First World War. Working in field hospitals along the Western Front, he'd seen firsthand how bacterial infections decimated the troops. After the war, Fleming came back to St. Mary's Hospital at London University, where he set about finding a way to find the microscopic enemy that was needlessly taking so many lives. The first thing Fleming did was prove that the traditional antiseptics the doctors were using were actually doing more harm than good. Because while they worked well on the surface, deep inside the body, those same antiseptics actually protected the deadly bacteria that was killing so many patients. Fleming also discovered an enzyme called lysosome in our body's skin, tears, and secretions that actually inhibits bacteria from growing. But it was only effective against relatively small amounts of bacteria. And given the enormous amount of germs and bacteria present in pneumonia and other infections, even culturing it in egg whites couldn't produce enough lysosome to make a big enough difference. By 1928, Fleming was working on Staphylococcus, the family of bacteria that can cause horrific infections through the toxins they produce or once they penetrate the skin. If you've ever had a staph infection, then you know. They're awful. In August of that year, after months of working in his lab nonstop, Fleming needed a break. He decided to head away for a short vacation back home in Scotland. And thankfully, Alexander Fleming was a bit messy. Notorious for his frequently untidy workspace, Fleming inadvertently left several petri dishes sitting on his workbench while he went out of town, which happily the cleaning woman didn't throw away. Inside the dishes were staph cultures, one of which contained a mold fungus that had grown in Fleming's absence. When he got back from the holiday, Fleming noticed that the staph cultures around that mold had all died, and offhandedly remarked, "Well, that's funny." When he showed the dish to someone else, his colleague reminded Fleming that this was similar to how Fleming had discovered lysosome. Fleming soon identified the mold as penicillium, and soon penicillin was born. But that's not the end of the story. Like lysosome, making enough of what Fleming called mold juice wasn't easy. Fleming wasn't even sure it could be done, so Fleming left it to two other scientists named Howard Florey and Ernst Chain to figure out how to mass produce penicillin. And Florey and Chain searched far and wide to find the perfect medium to produce the right kind of mold in enough quantities to make enough quantities of penicillin. By 1941, the two had enlisted a biochemist named Norman Heatley. Now, with Europe already suffering the effects of World War II, they needed funding and a safe place to do their research. So the team contacted the U.S. Department of Agriculture, and Florey and Heatley flew to the United States to set up a lab in Peoria, Illinois. They tried everything to find the right medium to grow enough mold to produce the amounts of penicillin they were looking for, even corn liquor, a byproduct of the massive amounts of cornstarch that was usually just dumped in the Illinois River. When that didn't work well enough, they enlisted the U.S. Army Transport Command to bring them anything that could grow mold. Cheeses, bread, rotten fruit, even samples of soil. But it just so happened that an assistant returned from the local market one day with a cantaloupe. A pretty moldy one too, penicillium mold, which ended up producing hundreds of times the amount of penicillin Fleming had ever managed, and much more than the Peoria team had imagined. Flory, Chain, and Heatley figured out how to enhance the process, and shortly after Pearl Harbor, hundreds of millions of units of penicillin were being mass-produced. And that mattered later too, because by the time D-Day rolled around in 1944, the Allies had enough penicillin to care for every soldier at Normandy. Meanwhile, the German army didn't have penicillin and was still using ineffective sulfa drugs. That meant Hitler's armies had to devote more time, people, and resources to Germany's casualties, and fewer soldiers recovered well enough to rejoin the war. The Allies, though, didn't have that problem. With more wounded soldiers getting better, faster, and fewer doctors and nurses needed for hospitals, the Allies were able to advance more quickly. Basically, how Cantaloupe helped win the war. The point of that story? Who knows where the answer will come from, but right now a lot of people out there are looking. Maybe one of these days we'll know their names too. Sometimes the answers do come from the most unexpected places, and people most of us will probably never ever meet are working right now day and night trying to find those answers. Back with more life after this.